In this discussion video, we will do a revenue example. So it says that a store charges $4 for a new item, and the demand is 60 items in a week. So that means there are 60 items that are going to be sold in a week at that price. If the store goes on a sale wherein they decrease the price by, this is 25 cents in a week or a quarter of a dollar, which increases the demand by 40 items per week, at what rate is the revenue changing? So I need to first do a quick kind of overview about revenue. So revenue is the money received from selling some item. So it's just the overall money received from selling some item. It doesn't take into account cost. So it's not profit. Profit takes into account revenue as well as cost. It'll subtract the two. Okay, so if I want to figure out the money that we receive from selling some item, this is going to be the price of the item times the quantity that is sold. But the quantity that's sold, this is referred to as the demand. The demand is how many people will actually buy it at that particular price. Okay. All right, so in terms of variables, I'm going to call the revenue R. I'm going to let P, lowercase p, be the price. And for demand, I'm actually going to call it Q. That's usually the convention, because Q stands for quantity, and quantity is the same as demand here. So Q is going to represent the demand. So that'll give me the equation R equals P times Q. So we're going to be working with this equation. All right, so that said, I want to now give you 4 minutes to try this question. 4, 3, 2, 1. Pause it for 4 minutes to try this. All right, so hopefully you did that. Let's talk about it together. So this is our equation. We're doing things a little bit out of order. Sometimes we can write the equation first, and I'm going to now write what we know and what we want to find after that, and that's okay. I wanted to write down the equation first, just so we know, like, oh, what are we going to go off of? All right, so we know the rate at which the price is changing. We know dp dt. And it tells me the price is being decreased, so I know it's going to be a negative value, and this is 1/4. It's a quarter of a dollar. All right, we also know dq dt, that rate at which the demand is changing. And that is increasing, so it's going to be a positive number, increasing by 40 items per week. Okay, and I want to find the rate at which the revenue is changing. I want to find dr dt. Okay, and I want to find dr dt specifically at this instant. Okay, so I want to find dr dt when, at this instant, when the price is $4 and demand is 60. Okay, so let's do the derivative of our equation. Let's do ddt of both sides. So ddt of both sides. So we'll get ddt of r on the left and ddt of pq on the right. So ddt of r, using implicit differentiation, is just dr dt. On the right-hand side, we'll need a product rule. So we'll get the first function, p, times the derivative of the second, which is dq dt, plus the second function, q, times the derivative of the first, which is dp dt. And now we can plug in the stuff that we know. So dr dt is equal to, well, the price at this instant is 40. Okay, actually, no, I got that wrong. The price wasn't 40, it was just 4. Okay. Price was 4. All right, price was 4, and then times dq dt was 40. So that may have been where I was getting confused. Okay, and then plus q, my q value at this instant is 60. And then times dp dt, which is negative 1/4. Negative 1/4. So if I simplify, we get dr dt, the rate at which my revenue is changing, is 160 minus 15, and that is 145. Last thing I need is units. So the units of revenue on top is how we're measuring money here, which is in dollars. And over the unit of time in this problem, and the unit of time was per week. So $145 per week. Okay, so they would expect their revenue to increase by $145 a week at this particular instant. Okay, so this was a situation where I needed to use product rule in a related rates problem. So I want to give a quick follow-up just to make sure that we're comfortable doing these implicit differentiation questions and involving DDTs and product rule. So what if I had an equation that was like R equals P squared Q to the 1/3? So what if I put some powers on the P and the Q and I needed to do the derivative? Okay, and I need to do DDT of both sides. So I want to give you a quick 1 minute to try this on your own. 4, 3, 2, 1. Pause it for a minute to try that. All right, let's talk about it together now. So I need to do DDT of both sides. Okay, so DDT of R on the left, DDT of P squared, Q to the 1/3 on the right. So on the left, we'll get dr dt. On the right, we'll need product rule, which says take the first function, times the derivative of the second, and with implicit differentiation, the 1/3 will come down, and I'll get times Q to the negative 2/3. But then I got to do the chain rule step and multiply by the derivative of Q, which is dq dt. Okay, and then plus the second function, Q to the 1/3, times the derivative of the first. So derivative of P squared will start off as 2P, but then there's the chain rule step, and you got to multiply by the derivative of P, which is dP dt. So if I did need to do product rule and implicit differentiation with a DDT on something like this, this is what it would look like.